Right. So the second part of this handout, timelines. Right. So how do we deal with timelines? So is timeline an easy way of doing things? Yes. Timelines can really give you a clear picture of what's happening. Right. Look what we have here. The time value of money. When interest is involved so the worth of money should not be judged only by its numerical value, but also by its position in time. You see, your money can lie in a certain position. Can be the first year, the third year, the fourth year, the fifth year. So you also need to know the time. Suppose the interest rate is 10% per annum effective. What would be worth more to you? 1,000 received today or 1,200 received 2 years from now on? We can only really compare the amounts at the same point in time. In order to do this, we have to apply 2 years of interest to the 1,000 rand to see what it will be worth at the point in time that the 1,000 was received. So to do that, we work out the compound interest like normally. 10% is 0.12 over 2 years, and we get 1,210 rand. Now, thus, we see that the 1,000 received now, right, in fact, is worth more than the 1,000 received in 2 years' time. So now you can really see it is worth more. Now, it's still very theoretical and very abstract. So to make it more clear, it is nice to have a picture. So it helps us to visualize how the value of money changes over time. Now, a timeline is very useful, people. We use T0, T1, T2, etc. to indicate the different points in time. We can use months, quarters, or years, or whatever the period is convenient for our interval. So that is the first thing, that is your timeline. Always start by T0. Like this one is over 8 years. Now, timelines are especially useful in dealing with cases where there are changes in the interest rate, because somewhere along the line, you can change the interest rate. Or when multiple amounts of money are paid, received at different points of time. So sometimes after 2 years, you can put more money into your investment, or you can withdraw money. So then how will it affect your final amount? So it's good to do it on a timeline. Let's do our first example. Change in interest rate. Let's do a timeline where the interest rate will change over the period. Example, Sibusiso deposits 15,000 into his bank account and leaves it in the account for 5 years. So on the timeline, the period is 0 to 5 because it is 5 years. But for the first 3 years, right, the interest is calculated at 8%. So for the first 3 years, so it's T0 to T3, it is 0.8. Remember, 8%, 8 divided by 100. But now why divide by 12? Because they say compounded monthly. So I hope that makes sense. Then the interest rate changes now to 9%. So from year 3 to year 5, it will change now to 9%. So it's 0.9 over 4 now, right? Is it clear, guys? And this time, not monthly, but quarterly. So how many quarters in a year? 4. So there you are. Remember, there's 2 years left. So therefore, 8 quarters. This was 3 years. So how many months? 36 months. I hope it makes sense now. So let's work it out now. So there you are. There's the first one, the first 3 years. It is a multiplier effect, don't forget. So times the last 2 years. So clear, guys? The 15,000 is only used once because the 15,000 that didn't change. The 15,000 remained 15,000 throughout. Remember, the 15,000 didn't change. So that is your first 3 months, and then your first 3 years and your last two years. So there you are. First 3 years and your last 2 years. and you multiply the two. Remember, do this in one step on the calculator to avoid premature rounding. That is the multiplier effect, right? Multiple payments and withdrawals. Let's see how this happens. When multiple amounts of money are involved, each amount can be moved around on the timeline separately. This way, complicate calculations. So let's see how can we do this one. For instance, Cheryl's bank offers 3% per annum compounded monthly on her savings account. She opens the account with a deposit of 12,000. So there you are, deposit of 12,000. A year later, so T1, she deposits another 5,000. Can you see, guys? Another 5,000. So that is 12 months there. Am I correct? Then another 2 years later, she withdraw 8,000. So another 2 years down the line, so it's now the third year now, she withdraw 8,000. So how many years is still left? Another 2 years, isn't it? And all of this, of course, guys, is done monthly, isn't it? Compounded monthly. So that 1 year is 12 months, 2 years is 24 months, another 2 years is 24 months. The interest rate did not change, so it remains 0.03 over 12. Remember, it is monthly. Now, there are changes here, people. The amounts changed. Like the previous one, the amounts didn't change. That's why we had to multiply. Here, the amounts changed. So, therefore, we do each one individually. So, 12, that one, plus that one, minus that one. Remember, withdrawal is minus. So this is not a multiply effect because see 12,000, 5,000, 8,000. The amounts changed. How is this clear, guys? Again, do it in one step on the calculator and you get your answer. Cool. Right, next one. Samba intends to give 100,000 to each of his 3 children when they turn 18. Now, they will turn 18 in 1 year, 3 years, and 6 years from now. You will give them the money on the same date as today in each respective year. For this purpose, he immediately invests a lump sum of money into his savings account, which pays 6% compounded monthly. How much must he invest? So remember, Samba already know how much he's going to spend. So he must now make sure that he deposits enough money to ensure that there will be enough money to pay his children. So in other words, it's a matter of working backwards now, you see? Because you're already spending the money, but how much must you invest? So you're working from the back to the front. So there, 12 months is the first 1 year. Remember that 1 year? Then you get 24 months. So from there to there, so 3 years. And then, of course, your 6 years. And in each case, you must pay out 1,000. That's the guide. So there you are. The years is done in reverse. That's why you have negative, negative, negative. That is negative 12 for the first child in 1 year. That is 3 years for the next child, 3 12s. And then, of course, 6 12s for the next child. But the exponents are negative because remember, you're working from the back forward. So don't forget that. And there you are. All of this in one step on the calculator, and you should get that answer. Please go through it again slowly and make sure you understood. Right. Thanks, guys. End of the video.